You'll find that the if function in Excel is extremely useful. All we need to do now is explain its extreme usefulness, and you'll never do without it again. Now, in essence, there are really two reasons for wanting to use an if statement. First can be in our example here on the simple if workbook, and then the if sheet. We have a set of pupils, we have their score, and we want to know whether they've passed or failed a simple if, really. If their score is above 60, they've passed. If not, then they've failed. So our syntax for our if statement starts, as all functions do, with an equals sign. So equals if, open brackets. Then we get Excel to help us out with all the parameters we need. Firstly, we need a logical test. My logical test is whether that person's score there is greater than 60, comma. The next part of the input parameters for our if statement is what to do if the logical test proves true. If it proves true, i.e. their score is greater than 60, then they've passed. So I'm going to output the word pass, comma. Notice the speech marks around the word pass because I want that to be a literal word pass to appear in the cell. Then my comma for what to do if the logical statement fails, so it's false, i.e. they have scored less than or equal to 60, well, they failed. Fail. Again, it's within speech marks because I want that to be the literal value that appears in the cell, and then close my round brackets for my if. Return, and we see that Mike has failed. Now, just like all the other functions that we will use in Excel, unless we fix a value, the function stays relative. Therefore, I can then replicate this formula to the bottom, and each person then has their score. Fail, 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 pass, and a fail. Not a very good class, really. Now, one way of enhancing this particular formula is to remove the 60, the pass rate, from the formula and place that in a cell. So I were to go over here, say pass rate, and place my 60 in here. And what I can do in my formula is obviously then reference that cell instead of the fixed 60 there. Pick up this cell here. Now I know from previously that if I now replicate this formula down, the J1 will move, but I want the J1 to stay in place. So I fix that with my keyboard shortcut of F4. So it fixes the whole cell as in the column and the row. Now in essence, we would get away with just fixing the row because we're only going to use this formula in this column. So as we move down the column, we would want it to stay in row 1. But it doesn't hurt in this particular case to absolutely fix that cell reference. What we then do is we then replicate the formula. We currently have the same results because we're checking the same previous score, which is 60. But what we now have is the ability to change the pass rate in one place. Instead of changing all the formulas, we change it over here. And the examiners decide that being a little bit tough this year, they're going to change the pass rate down to 50. And then when we press return, we find that that allows a couple more people to gain the pass score and therefore go on to bigger and better things. So that's one use of an if statement, to compare the values in one cell, possibly against another, possibly against a fixed value, and return a text value. Text value if the statement is true, and a different text value if the statement is false. Now, a second use for the if statement, we have here an example in the second sheet called errors. Now, each of the cells here, B1, B2, and B3, contain a formula, and I've shown the formula over here on the left so you can see what the formula is. But they're all three of them generating a standard Excel error message. And the error message for the first one is div O because we're trying to divide by 0. We're effectively dividing this cell by itself, which is possibly not what we were trying to achieve. Let's change that to divide by D1. We're still getting an error message because the cell D1 is empty. So what I do to try and negate the error message is go into the formula and carry out an if statement before I even attempt to divide by. I say if D1 equals 0, then don't actually put anything in the cell, which I can achieve with a double set of speech marks. So effectively opening a literal string and closing it straight away. Then I have my second comma and I'm into value if false. What I want to happen if this is false, so D1 is not equal to 0, is to actually go ahead and carry out the division. And then close my brackets, return, I then have an empty cell, which I'm not that keen on. So what I'm going to do is I'm going to edit the formula and just put a little hyphen sign in there. That way I know there's something in that cell and I don't inadvertently delete the formula. What you'll notice here on the left is, let's just widen that. I have a formula showing the current formula within this cell so we can see what's happening. So I've negated the error message there by effectively checking the value of the cell that is causing the error message. Now the second one is slightly different. This is hash value. That's because one of these cells doesn't actually contain a numerical value. Now, this is much harder to check because I would need to check all three cells, which would require me to have three ifs within the statement. Or, a little bit clever than that, let's go in and say, okay, equals if, open brackets. We're going to use a clever little formula called is_, which we will see in action much later and have it much more deeply explained. But what it's checking for is if there is an error in that adding up. So if those three cells being added up causes an error, then we get a true. If it doesn't cause an error, then we get a false. Thus allowing us to continue with our if statement and say, okay, if the is gives me a true, so there is a problem, I'm going to do the same as the first one, speech marks, hyphen, speech marks, comma. If, however, there isn't an error, then I'm going to go ahead and add up the contents of those three cells. So C2 plus D2 plus E2. Close brackets for my if statement, return, and I just need to widen A a little bit, and I can see that I'm getting a hyphen because there is something wrong with one of these cells. Just to make sure that these work, I can put numbers in the three cells and the result appears. Same with the division. Put a number and another number and the result appears. So my if statement is working. It's checking for the error. If there is an error, don't do anything, just put a little hyphen. If there isn't an error, then proceed and do the formula. And the same with our last little one here, hash num. This is being caused by the fact that we are trying to do to the power of this cell to the power of this one, and you cannot do that to empty cells either. If I were to put some numbers in, 4 and 4, you see we get the results. That's 4 to the power of 4. So to negate this problem again, notice if I delete that side, it still works. So it's this one here, the C, that's the issue. So I need to check for C3. So equals if, open brackets, C3 equals 0, then do my little hyphen thing. If not, then we'll go ahead and do the to power of. Close the if brackets, return, and I see a 1, but if that 4 is not there, I get my little hyphen again. So that's the if statement in action 1, as we've seen here, to negate some of the error messages that you can get in Excel. Obviously, you'd need to know how the error was being caused so that you could check for it. And the second, which is the first thing we actually looked at, which is comparing, in this case, two cell contents to then decide on a text output.